So once again, good morning, students.
Good morning, teacher.
Yes, good morning, and welcome to our class of today. Okay, so last meeting, we discussed regarding geometrical constructions, and we talked about triangles. We talked about angles last time. Okay, and what else? We talked also about the sides of triangle and its bisectors. Okay, today we will continue still about triangle, but this time we focus on bisector. Okay, perpendicular bisector, or that means bisector means the line that will bisect or the line that will divide. Okay, so in simple term, we can compare that one. A bisector is a line that will divide the triangle. Okay, so that is a bisector, and it is called perpendicular bisector, perpendicular line, because it will form 90 degrees to the side of a triangle. Okay, so that is why it is named as perpendicular bisector. Okay, so anyway, we will discuss that one, and then please also prepare your workbook. Okay, please prepare your workbook. Now, let me ask, who among you answered those pages that I told you to answer? That is just drawing. Anybody? Page 113. Did you answer? Anyone? Panya? Muta, did you answer? Okay, Chumpu is now here.
No, too many homework.
Oh, too many homework. Okay, anyway, so as fast as we can. Yes, Panya, did you answer already?
Not yet.
Not yet. Okay. Okay, anyway, what about the others? Who answered? Anybody of you who have answered? Okay, Te is now here also present. Okay, so we will make it faster a little bit, our discussion, so that if we can finish it early, our discussion, then we will have to answer the task that we have. Okay, so let's go. Let me share our discussion for today. Okay, so here it is. Okay, so this was the task last time that I told you to answer. Okay, and you said you have not finished and others are still going to answer that task. Okay, I understand because you have so many tasks. Okay, you have so many, right? Is it many? Muta? Panya?
Yeah, a lot now.
A lot,
Yes.
huh? Okay, so anyway, we will make it fast as we can so that we can also answer the task. Okay, so let's go. Perpendicular and angle bisector. So in this topic, we will be learning page 118 if you want, okay? 118, 118. Okay, so going back, in this topic, we will be learning how to construct perpendicular and angle bisectors. Okay, so that is the focus. We don't have problem solving, but it is all about constructing perpendicular and angle bisectors. Okay, circumcenter, we will not discuss also about that one. Again, we focus on construct perpendicular and angle bisectors. Okay. Perpendicular bisector theorem. Panya, please read.
Yes.
Okay, please read. If a point
is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment.
Okay, so according to this perpendicular bisector theorem, if a point is on the perpendicular bisector segment, then it is equidistant from the endpoints of the segment. Okay, so this means that if the bisector, okay, take note, this bisector, this arrow is what we call as the bisector of the segment, forming 90 degrees. Again, a bisector will divide the triangle forming 90 degrees. Okay, so take note of this one. This is 90 degrees. Now, if a point is on the perpendicular bisector of a segment, then it is equidistant from the end point. So that means if we have this point in here, then segment PE is equal to segment AE. Okay? So because your point is at the center of the perpendicular bisector. So that means that this side is also equal to that side. And of course, this side is equal to this side. Okay, so that means that this side is equal to this side. So therefore, if the bisector is at the center, we take it at the center, then this side is equal to the opposite side. That is when a point is on the perpendicular bisector of a segment, then it will be equidistant. Equidistant means equal distance. Okay, so from here, it will be equal distance to the endpoint, and here also is equal to here. So PE equals side AE. So that is equal. That is what we mean by equidistant. Okay. Now, let's proceed. Okay, here. Converse. Okay, so that means, again, if you point, it will be equidistant. Now, converse of perpendicular bisector theorem. Pokpong, please read. Pokpong, you read.
If a point is equidistant from the endpoint of a segment,
Okay.
then it is on the
Perpendicular bisector of the
segment.
Okay. So what does it mean? Converse of perpendicular bisector theorem. If a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector. Now take a look of side ST and segment YT. Okay, so that means that if the two sides of the triangle are equal and a perpendicular bisector is being drawn at the center, so that means it forms 90 degrees in here. So therefore, since these two sides are equal, so segment ST, this side is equal also to the other side. Why? Because these two sides of the triangle are equal. So when we divide that one, so it will be divided into half equally. Okay, so that is why we said that this side is equal to the opposite side, considering that this, okay, is also equal to this side. Okay, so that means this is an isosceles triangle. So if we divide an isosceles triangle equally, so therefore these sides are equal also to the opposite side. This is what it means with the converse of the perpendicular bisector theorem. Okay, so if you look at it here, this is just the same with here. But here we consider the side from the center point. And it will be also, this segment is equal. Okay? So if we compare the first discussion, that one, it is just similar. But the difference there is, okay, example number 1, we consider this side. Okay. Example number 1, we consider this segment and this one. And example number 2, we consider, okay, we consider okay, so what happened? Okay, so we consider the side in which there is that perpendicular bisector to be equal. Okay, so far, do you understand our discussion? Perpendicular bisector. Okay, so again, if the two sides are equal and you divide it, okay, perpendicular bisector at the center. So if you take a point at the center of the triangle, it will be equal. That is perpendicular bisector theorem. And then the converse of that theorem, if two sides are equal and then divide it with a perpendicular bisector, so from the 90 degrees angle below, it is equal in distance, equidistant as we said. Okay, so that is just easy to understand actually. Okay, so perpendicular bisector, why it will not move? Oh no. Okay, let me check again. Just one moment. Okay, so let me share it again. Okay, so we will continue. Okay, so we are now in here. Okay, so that is converse. Now, much more examples. Find each measure. Okay, so you have there example number 1. Take a look. One side or side BO is 15 and YO is also 15. Why? Because this bisector line here, okay, this bisector line is dividing it equally, forming 90 degrees. And this side also is equal to the opposite side. Okay, so that means that they will have the same length. If that is BO is 15, so YO is also 15 because the perpendicular bisector here divide it equally. Okay, divided it equally. So therefore, this one is also 15. Okay, so you have there YO equals BO and equals to 15. YO is 15, BO is 15 as shown in this example. Okay, number 2, GR. Okay, so GR here, this is side GR. Okay, so take a look. GI, okay, this side is equal. Take note, this is 20 and this is 20 also. So therefore, that is equal and divided by this, okay, by this perpendicular bisector forming 90 degrees. So therefore, 2x is also equal to x plus 8. Okay, so 2x minus 1 is equal to x plus 8. Why equal? Because again, the two sides of this triangle are equal. So therefore, when we divide it, perpendicular bisector at the center, then this side is also equal to the opposite side. Okay, so that is, or those are examples of perpendicular bisector theorem and the converse of the perpendicular bisector theorem. Okay, so those are more examples. Going next. Okay, going next. Here, would you like to read? Okay, Muta, you read angle bisector theorem.
Angle bisector theorem is a point is on the bisector of an angle, then it is an equidistant from the sides of the angle.
Okay, so if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Okay, so here, we have here AN equals GN. So what does the example mean? Now, this is your perpendicular bisector at this point forming 90 degrees. Okay? So from this point also, if you draw a bisector this side and forming 90 degrees, that would mean that this side AN is also equal to side GN. Why equal? Because we divided equally this angle by this bisector. And if it will be from a certain point to the side of the angle, it is equal distance or equidistant. So that is why AN equals GN on our example. Okay. So again, we divided this angle equally. So therefore, from this point to the other side and this point to the opposite side, forming 90 degrees angle, the sides are equal. Okay. So let's now go to converse of the angle bisector theorem. Will you please read Te? Okay, Te, please unmute.
Yes, teacher.
Okay, read this one. This one, this. Converse of. Okay, Te, you read. Converse of the angle bisector theorem. Okay, so if a point. Okay, please read. If a point
Is a point
is equidistant distant from the sides. Okay, try to read. Here, from from the sides.
From the side.
Okay, continue. From the sides of.
From the side of.
Okay, this one, continue. Of an angle.
And oh,
This one. Read.
this one.
Then
Then
it is
it is
on the
on the
angle.
angle.
This one. How to read? Okay, you read this one by. Oh, okay. You read. Angle bisector. Okay. So, you try to practice reading. Okay, so that will help also you. Okay, so according to the converse of the angle bisector theorem, if a point is equidistant from the sides of an angle, then it is on the angle bisector. Okay, take note, angle A, this angle, A, L, N. Okay, so that means, okay, so that means this angle here. So angle ALN is also similar to angle GLN. So that means that if a point is equidistant from the sides of an angle, then it is on the angle bisector. Okay, so this is the angle bisector. Okay, so if the sides of this, okay, this angle is equal to this angle, then they lie on this angle bisector. Okay, so that is what we mean by the converse of the angle bisector theorem. So if a point is equidistant from the sides of an angle, so this side and this side, so therefore it is on the angle bisector. So angle ALN is similar or the same with angle GLN. Okay, angle ALN is similar to GLN. Okay, so that is to show this, okay, angle bisector theorem and the converse of the angle bisector theorem. Okay, so do you understand so far to our discussion?
Yeah.
Yes. Okay, so let's try to answer page. Okay, so that is all about angle bisector. Okay, so we will now go to our task so that if we can finish, then you have no more thing to do. Page 118. Okay, please have your workbook. Do you have ruler and compass with you? Okay, please prepare also ruler and compass. Okay, you have 1 minute to get it. Get ruler and compass. Okay, you have 1 minute so that we can answer our activity. Okay, that is why I told you last meeting that we will be using ruler, compass, and if you have set square, then we use also set square. 45 degrees set square or 60 degrees set square. Okay, so we still have time, so I think we can answer the task that we have today. Okay, page 118 of your workbook. Page 118, number 7, using only a ruler and a pair of compasses, construct the following triangle. Okay, so what we do here is to construct or create the triangle as described on excuse me. Okay, so so again, we construct a triangle using compass and ruler. Okay, so number 7, letter A. Okay, so this is number 7. Okay, so okay, 7, letter A. Okay, so construct triangle MNK with side MN equals 4.5 cm and angle KMN equals 60 degrees and angle MNK equals 45 degrees. Okay, so what you will draw first is the angle or the side for MN, which is 4.5. Okay, so if this is your, okay, here, this is MN. Okay, so this is your M and N, which is 4.5 cm. Okay, draw angle KMN 60 degrees. Okay, so you have now decided to create an angle 60 degrees. Okay, 60 degrees, it will be like that. And you have that one, angle K. Okay, so this is KMN. So this one is 60 degrees. Okay. And this is 4.5 cm. Okay. Then angle MNK is 45 degrees. So this one, okay, so from here to this one is 45 degrees. Okay, so this is now 45 degrees. And this will be your answer for letter A. Okay, so your triangle will be looking like that. But take note, use compass in order for you to get 60 degrees and 45 degrees. Okay, so as you can see, you have their side 4.5. So this side 4.5 and angle KMN is 60 degrees. Okay, so this one 60 degrees. And angle MNK. So this angle is 45 degrees. Okay, so it will be looking like that. So please draw that one in your workbook. Okay, you have 30 seconds. Yes, Muta?
Nothing.
Okay, so please draw that one in your workbook. That is letter A. Let's now go to letter B. Okay, so we put letter B in here. Okay. Letter B, triangle ABC with AB 4 cm, ABC 120 degrees, and angle BAC is 30 degrees. Okay, so the same step, because that is similar for letter A. We drew first side side 4 cm. So we draw first side 4 cm. Okay, and then so we label that one as side AB. Okay, side A and B. Okay, so you have here B. And next, angle ABC is 120 degrees. So this is 120. Why not straight? Okay, that is 120 degrees. That is obtuse. Okay, so more than 90 degrees. So that is angle A, B, and C. Okay, so this is your C, which is having 120 degrees. Okay, and then the third angle, angle CAB. Okay, so this one, C. Oh. Okay, so angle C, A, and B here. Okay, so that is how many degrees? 30 degrees. Okay, so your triangle will be looking like that. So you have here 4 cm, and then you have 120 degrees angle ABC, and 30 degrees angle C, A, and B. Okay, so it will be looking like that. So please follow, please draw that one in your workbook. Okay, so letter C. Okay, letter C. Triangle PQR equals PQ equals QR 3.5 and RPQ is 45 degrees. Okay. So again, side PQ. Okay, so if this is PQ and QR, PQ and QR. Okay, so QR. Okay, so we label this one first. This is your side P and Q. And QR, okay, is also equal. So this is equal inside here. And then side RPQ is 45 degrees. Okay, so this is R, P, and Q. So this angle now is 45 degrees. Okay, so your triangle will be looking like that one. That is for letter C. Okay, so this is 3.5 cm. Okay, and this one also is 3.5 cm. Okay, are you doing it now? Anya, did you make it? Did you draw? Muta, Pokpong? Yes, okay, yes, okay, thank you. What about the others? Are you making it? C? Okay, Kankawi, Kaukong, Shumpu? Okay, so please have that one drawn in your workbook. Okay? So that is for number 7A, B, and C. Okay, you have 1 minute to finish that one. We will go to number 8. Okay, finish. Make it a little bit faster. Make it a little bit. Okay, who was that? Muta or Panya?
Muta.
Okay, finish.
Yes.
Okay, Panya also is finished. What about the others? Kaukong, Kankawi, Chumpu? Okay, make it faster so that we can... No, okay, make it faster. C. Take note, use ruler and compass, okay? The angle in there is just estimation of me, but your triangle will be looking like that one. Okay, now? Oh, we have less than a minute already. Okay, so I think you continue number 8. Okay, you continue number 8. So that is page 118, 119. Okay. So that will be all for today. And thank you everyone for your participation. Okay. See you again on the next. And please do the exercise or your task. Okay.
Okay.
So bye-bye for now. And you take care always.
Bye-bye, teacher.
Bye-bye. Okay. Thank you.
Bye-bye, teacher. Bye.
Bye-bye.
Thank you, teacher.
You're welcome.